folks, welcome back. We're going to look at least squares regression lines today, also sometimes just called Lsrl or line of best fit, or just a regression line, or a trend line. All of these basically mean the same thing. A least squares regression line is computed by a computer rather than, maybe a line of best fit. You might just pick a couple points and try to eyeball it, but they all generally mean the same thing. So let's specifically talk about the Lsrl. There's two reasons for modeling scattered data with the best fit line. One is so that the trend in the data can be easily described to others. So easily describe the trend without giving them a list of all the data points. The other is so that predictions can be made about points for which we do not have actual data. The second one's probably the more important. I don't know, maybe someone you're talking to needs to know the equation. But usually they just want to know the answer. They want to give you, the person analyzing their data, all the numbers and say, hey, here's the data I have. What can you come up with? What are your predictions based on that data? Predictions are why companies are interested in our data, right? That's why Google and Facebook and everybody collects our data, because they want to be able to predict what we're going to buy in the future and what we're going to do online and all that good stuff. So, predictions, important stuff when you're talking about data. A unique line of best fit data, a unique best fit line for data can be found by determining the line that makes the residuals, and hence the square of the residuals, as small as possible. So the residuals, remember, is the distance from the actual data to the predicted data, or to that line. We call this the line of we call this line the least squares regression line, and abbreviate it Lsrl. A calculator can determine the Lsrl quickly. Statisticians prefer the Lsrl to some other best fit lines because there's one unique Lsrl for any set of data. So if I crunch the numbers in Excel or on Google Sheets or in my calculator or by hand, and I'm using the techniques for the least squares regression line, I'm going to get the same equation. Therefore, all statisticians come up with exactly the same best fit line and can use it to make similar descriptions of and predictions from the scattered data. So let's take a look at an example of some scattered data here. I put some stuff over in Desmos for us to look at. So here I've created a plot of hours studying and doing homework versus the test grade. So our y-axis would be your test grade, and our x-axis would be the number of hours that you studied and did homework to prepare for that test. If you take a look here, we've got the green dots are our data points. You'll notice that there's 1 point there for each of the lines in our table. And we found the Lsrl in Desmos pretty quickly by going back to our equation for a line y equals mx plus b. And instead of y equals mx plus b, we're going to write y1 tilde, it's a little squiggly, on the top left of your keyboard, if you're doing it with the keyboard, mx1 plus b. So we just replace the equals with the tilde, and we add a 1 to our x and y. That needs to match the heading titles in our column. So if this was x2, y2 in the columns in the table there, then we would make it x2, y2 in our equation. But we're just doing 1 and 1 here. And then it goes ahead and it computes that line. And it goes right there through the middle of my green dots. I've got the purple line. And if I want the equation, I can look down at the bottom here, and I get my m, which is my slope, and my y-intercept, which is right there. So if I had the equation for the line of best fit, it would be y equals 8.93 x plus 56.61 if I was going to round it 2 decimal places. So I took that data and I took a screenshot of it and have 2 questions for you to answer on it. What is the expected grade of a student that spent 2.2 hours doing studying and doing homework, in other words working for their test? And 2, based on the equation, how long would you need to work to get a 100%? Sorry about the typo there. Answer those 2 questions. Be ready to talk about it in class. All right, thanks.